Hi everyone, I'm back with another Math0824 example. This is still chapter 4. It's kind of 4.3 with the AC method, but this text doesn't really cover the cases for which A is larger than 1. So I mentioned in my previous videos, if you want to see a nice example, or if you want practice on this, you can go and look at the free Math0823 textbook, which is on the CCBC Math website. So let's go ahead and get started. So remember, the first thing you always do is you look for your GCF. No matter how many terms or what you're doing, if you're factoring, you want to see, okay, what is the greatest common factor? So let's see what we have here. We have 18, which is 3 times 6. We have 33, which is 3 times 11. And we have 30, which is 3 times 10. So it looks like we can factor out a 3. We also, if you notice, have x's in each of these 3 terms, so we can also factor out an x. So remember, factoring this out is the same as dividing each term by 3x. So to figure out what goes in here, what's left over, we just use division. Okay, so now we're going to proceed to use the AC method, but we're going to only use this part of it. Okay, so let's see what we can factor out here. Okay, well, let's go through and identify A, B, and C. So first we have a 6, and then we have 11, and then we have negative 10. So that means that AC is negative 60, and B is 11. So let's think about some of the numbers that go into 60. And anytime that you have this sort of problem, you can go through and create a prime factorization tree if you're having difficulty coming up with new factors. Okay, that can help you. So let's see, what should we start with? Let's start with dividing by 5. Okay, so AC is negative 5 times 12, okay? So, but negative 5 plus 12, well, that's equal to 7, which is not what we want. So that solution is not going to work for us. All right, let's think of a different number. How about 3? How about negative 3 times 20? Well, negative 3 plus 20 is only going to give us, what, 17? And we want the number 11, so that's not going to work either. What about the number 4? I noticed that there's a 2 here and a 2 here. So that means that 60 is divisible by 4. So 60 is negative 4 times 15. And luckily, 15 minus 4 is 11. So we have our solution. Okay, and again, remember, I've said this before in my previous videos, you cannot simply write this as x minus 4 times x plus 15 because your leading coefficient is larger than 1. Even down here, it's larger than 1. Okay, and again, if you FOIL this, if you don't believe me, go back and FOIL this thing and prove to yourself that you don't get the example, the problem that we started with. Okay? So what we have to do instead is that we have to use our rewriting and then factoring by grouping technique. So as I do this, I'm going to go through and try to make sure that I write out this 3x because he's still part of the problem even if he's not part of the AC method. So I'm going to have 6x squared, and then I'm going to be rewriting 11x as the sum of negative 4x and 15x. And then we'll finish off, bring down the negative 10. Okay, so now I can apply factoring by grouping. So let's see, we have problem here. So remember, factoring by grouping consists of just throwing the first 2 terms together and then throwing the second two terms together, and then just asking ourselves, okay, well, what do they have in common? So I can factor a 2x here, and I'm left with 3x minus 2. Looks like over here I can factor out a 5, and I'm left with, again, 3x minus 2. Now I'm using brackets just to distinguish themselves so I don't have nested parentheses. You certainly can use two sets of parentheses. I just feel like it's visually confusing. Okay, so notice that these two terms are the same. They're the same, that means that we can factor them out. So we have 3x minus 2, and then what's left over is 2x plus 5. So that goes here. And as long as you didn't forget that 3x, which is still part of a problem, then you are done. That's it. We're done. That's the answer. All right, let's do one more problem. So in this problem, we have 8x squared minus 6xy minus y squared. So a lot of people totally panic because there's not one, but two variables here, okay? The good news is that we're going to treat it just the same way that we always have, and we're still going to have our A, our B, and our C, okay? So if you want to, you can pause this video and see if you can see how far you can get on the AC method. Otherwise, you can just watch me solve this. Okay, so we have an 8, we have a negative 6, and we have a negative 5. That means our AC is negative 40, and our B is negative 6. Okay, and again, I mentioned on the previous problem, if you're ever stuck, I'm going to ignore this negative sign for a minute. Okay, you can always just kind of go through and make a prime factorization tree. Okay, just to kind of get your brain flowing and help yourself think of different things that would go into 40. All right, so I'm going to start with, gosh, what should we start with? Well, let's just go ahead and start with 4 times 10, because that's what I wrote. So if I have negative 4 times 10, that works. Negative 4 plus 10, though, is a positive 6. So we need to flip those signs around. And that gives us negative 6. Okay, so that was our goal, was to get a negative 6. So this one will work. Okay, so now remember I mentioned earlier that you cannot, when you have an A larger than 1 like we do, you can't just write your factored form like that, right? You can't just write x plus 4 and x minus 10 and then be on your merry way. That is not the factorization of this problem. And again, you can totally prove that to yourself by foiling it, and then you will see that. Okay, so let's clear some room for ourselves and work through this. So we have 8x squared minus 6xy minus 5y squared, okay? And then we are expressing negative 6xy as negative 10xy plus 4xy, or you could write them in the reverse order. It doesn't really matter. Okay, so again, we have this factoring by grouping because we have 4 terms. And if you're fuzzy on that, go back and watch my factoring by grouping examples. So it looks like I can factor out a 2x here. And I have 4x minus 5y left. Okay, and then over here, it looks like I can factor out an x. And is that right? Oh, I'm sorry. I miscopied this. There we go. Okay. So I apologize. We're not factoring out an x. We're factoring out a y. There we go. All right. So then we have 4x minus 5y. Okay. So note that this term and this term are the same. So we can factor it out. Just like you factor out a greatest common factor, because that is the greatest common factor. And then what's left in the parentheses is 2x plus y. Okay? And remember, the beauty of these problems is that you can always FOIL. You can always go back and check your work, right? First, outer, inner, last, and make sure that you did the work properly.